In this video, let's take a look at standard IF.7. For standard IF.7, we need to analyze piecewise, absolute value, polynomials, exponential, rational, and trig functions, including sine and cosine, using different representations to show key features of the graph by hand in simple cases and using technology for more complicated cases, including domain and range, intercepts, intervals where their function is increasing, decreasing, positive or negative, rate of change, relative maximums and minimums, symmetries in behavior, period, and discontinuities. So this standard has a whole lot of stuff involved. But let's look at a couple of examples for this one. So question number 1 says, what are the x values for all of the discontinuities of the function? So we've talked before about how discontinuities mean there are either holes in the graph or there are asymptotes on the graph. So what I would recommend is we type it in Desmos and take a look at what's going on. Does it look like asymptotes or holes or a combination of the two? So let's see, wrong button. Let's pull up Desmos. And when you have a group of things in your numerator, you just want to make sure to put a parentheses around it. So x squared minus x minus 12 in my numerator, all divided by 2x squared minus 10x minus 28. Then hit home so it looks back to normal again. So I can tell there are two vertical asymptotes that look like they're occurring here. And you can kind of tell which ones make good sense, like -7 and 2. Let's just say I type x equals -7, but that's not where this graph looks like it's undefined. So like that would not make sense. X equals -4 is answer choice B, and that still does not make sense because that's not where this graph is not touching those values. X equals -3, we're getting closer, but that's still not it either. And then x equals -2 lines right up with where it looks like we have an asymptote. Then also for answer choice D, let's check x equals 7. And notice those are the two places on the graph that look like they are indeed undefined. So the best answer choice is D. Question number 2 says, what is the vertical asymptote for this function? So let's clear out number 1 and type that one in. So we have log base 3 of x minus 5 plus 7. And we just need to find the vertical asymptote. So it looks like it's right at 5. And just to double check, you can type that answer choice in and make sure it looks good. And indeed, it definitely is at x equals 5. You also can tell that that's the case because it shifted right 5 because of that x minus 5 in the grouping symbol. And that is what makes the vertical asymptote shift. So vertical, I didn't mean to write shift. Vertical asymptote goes with the fact that it shifts left or right. So it's at x equals 5 for that reason. Okay, moving on to number 3. Over which interval is the function 2 minus x to the 4th plus x to the 5th positive? So let's give that one a whirl. So 2 minus x to the 4th plus x to the 5th. Okay, so positive and negative we've talked about before. Positive is anything above the x-axis. That is considered positive. And then anything below the x-axis is considered negative. So on this function, I'm just going to do a little rough sketch over here. So it definitely looks like it's touching like right here. It goes up and touches and goes up that way. So the positive interval of this graph is this whole piece that's up above the x-axis, starting with this spot right here where it touches at -1. So you see that C and D would definitely be wrong because they start at 0. But our positive interval starts at -1 and then will continue to infinity. The only the only question here is, do we need a parentheses or a bracket? So what you want to think about in this case is at that spot, is it positive? and it is not positive or negative. So you want to go with answer choice A for that reason. Because if it was completely positive, you could use a bracket, but it sits right on the boundary of positive and negative, so we can't claim it as positive. You could think of it that way, so we have to put a parentheses. Moving on, let's look at number 4. So number 4 says, which choice describes the end behavior for this function? So let's type it in and see what's happening on the ends of our graph. So let's see. So if we do a little rough sketch of this function, it looks like it's going like this basically, which means that it's headed out toward the third quadrant. Excuse me, the second quadrant, not the third. This is the first quadrant. That's the second quadrant. This is the third quadrant, and this is the fourth quadrant. They make like a capital letter C is a great way to remember it. So the second quadrant is where we go to the left and up. So left and up means that X is negative and Y is positive. And then it's also headed down here toward the fourth quadrant where we have to go right and down. So that means X is positive and Y is negative. So that's what we're looking for, that combination of X being negative and Y is positive, and then X being positive when Y is negative. So we need to look for negative, positive, and positive, negative. So A is definitely not our answer choice for that reason, because that's negative, negative, positive, positive. All right, so then B says negative infinity for X and positive infinity for Y. So that's this second quadrant where our graph is headed in that direction forever and ever. And then it also says positive infinity for X and negative infinity for Y, which is what this other end of our graph is doing. So the best answer choice would be B. All right, let's look at number 5. It says, what is the range of this function? So use your resources. Use Desmos to type this in and just take a look at your Y values, which always go with the range. Remember, range is the lowest Y value to the highest Y value. So this function goes from negative infinity, because it's going down, down, down forever, up to negative 12. Pick out the Y value for that point, not the X. So we want to put it in that order. So negative infinity has to come first because that's the lowest. So A and B are out. And then it goes up to negative 12. But notice they did give you an option to choose the one with the X value, which you do not want to do that because the range needs to go with the Y value. All right, number 6 shows a piecewise function. So we just need to type this one in Desmos and find the y-intercept for this function. So notice they will give you a variety of functions and ask you all sorts of things about the graphs. That's what this standard is covering. So x squared minus 4, and then we need to put in our domain is from x is less than or equal to 2 for that piece of the function. And then we have another piece, 12 divided by x minus 4. And that's for values of x that are greater than 2. So we look at our piecewise function, but we really just need the y-intercept, which is at 0, negative 4. So all we needed to do for this one was type it in Desmos and find where x equals 0 or the graph touches the y-axis. Either way you want to look at it. Or both. That would even be better. All right. We have one more question to look at. Number 7 says a 50 milligram sample of cesium-134 has a half-life of 2.062 years. The function f of x equals 50 times 0.5 to the power of x over 2.062 can be used to calculate the amount of cesium-134 remaining after x years. What is the approximate yearly rate of decay? All right, so what I did was I took the function they gave me. Let's see. We'll just leave Desmos there, but clear that out for now. So 25, actually, let me just write the original one they gave me. So f of x is equal to 50 0.5 is my base, and then I have time over half-life, which is 2.062. Okay, but they want the approximate yearly rate of decay. So what we need to figure out is after a year, it'll divide in half, or excuse me, after this amount of half-life, it'll divide in half. So what I decided was 25 would be my final amount after 1 year. So I put 50, and I decided to just use it as a growth function because it wanted the rate of yearly decay. So 1 minus the rate, and then we know it would take 2.062 years for half of it to decay, so that's going to be my time, and then I'm going to use that to figure out the rate. So to solve it, I first divided by 50, so that gives me 0.5 equals 1 minus the rate that I'm looking for to the power of 2.062. So at that point, I need to take the root of this. To get rid of that power, I have to take the equivalent root, which is kind of a weird number, but it'll work in my calculator. So then I get 1 minus r on the right, and on the left, I can go down to the bottom of my functions menu in Desmos and get the nth root and put any root I want right there. So I'm going to put 2.062, and I'm going to put 0.5 to that root is 0.7145 equals 1 minus the rate. So then I'm going to subtract 1. So let me just scooch over here to the side and put that minus 1 would be negative 0.285 equals the negative r, which is the rate I'm looking for. Then I just got to multiply or divide both sides by -1, and I get 0.285 is the rate, which if I move my decimal back over, it's approximately 29%, which goes with answer choice B. Okay, so that is it for standard IF.7.